you have 1 unit, you have 2 units, and someone says, I don't have any design, please tell that also. Some center, some college will tell, my course doesn't have any design. If you have that, also tell. You can't write a course outcome for design, please mention it. Then we will see how to solve the problem. How to solve the problem. Then it's a serious issue. We have to think. We have to think. And let's see how to solve the problem. So in case you have an example that my course doesn't have design, please raise that also. As a first example, anyone who's going to raise the hand first will take the answer. We'll take your answer, and the question that we have received here, we'll answer the questions also. So let's be fast. Let us be fast. Please write for, look at where we have the design component, combine it into a single course outcome. Look into your course. Yes, we have a hand. Wow, so fast. Who's it? Karekudi is leading. Where are the other colleges? Please go ahead. Please go ahead. Let's encourage whoever is coming ahead. Yes, good afternoon.
I am taking this engineering subject. So this is partly theory and partly problem-oriented paper, madam. So in unit 1, we have a site investigation and site exploration. So there is the design component will not be comes under unit 1. So in unit 2 as well, safe bearing capacity. So in unit 3, we have shallow foundation. So in this unit,
No, I hope the question is clear. Pick up only those units which have a design component. Do not tell my unit 1 does not have a design. We request you to pick up the design component in various units.
third and fourth unit.
Highlight that. Yes.
So in third unit, design and construction of shallow foundation. So in unit 4, design and proportion of pile foundation.
Okay. Yes. Unit 3.
Design and proportion of shallow footing.
Okay.
And unit 4, pile foundation. So for this, design and proportion of a pile foundation.
Fine. How unit 1, 2, 3 you have said. How about unit 4 and 5?
In third unit, we have shallow foundation.
Okay.
In unit 4, we have pile foundation.
Okay.
In unit 5, air pressure theory, there is no design. So it doesn't take in fifth unit.
Okay. So please state the course outcome. So you have the design component in 4 units. First 4 units. Last unit we are not having a design component. Absolutely fine. Please give the course outcome.
Design and proportion of shallow foundation and pile foundation.
Okay. This is a question that can be asked in the theory exam. Okay, our focus right now is on the theory course. Okay, GC Bakur. Yes, please go ahead.
Write a HDL program and design a 8:1 multiplexer using 4:1 multiplexer.
Your audio is not clear.
Write a HDL program to design a 8:1 multiplexer.
Yeah, don't make it so specific. Yeah. Yes, GC Bagur, I think is presenting. Please go ahead. Please let us not be so specific. 8:1, 4:1. Design multiplexers. That's it. Let's not have so specific specification. Design multiplexer. We can give anything. Yes. Next, please go ahead.
only one CO in the particular subject matter, VLSI design. So that is not the design. So for that particular unit, we have written only one.
Okay, only the last unit has the design component and you are writing multi. That's fine, absolutely fine.
Yes,
So
ma'am.
here we have an example where one unit only is having the design component and we are able to write the course outcome. So let's move ahead. I know there are many more who have raised the hand, but let's move ahead. Here we had a question from a faculty who's attending the session here. And the faculty asked us, what happens if my course doesn't have any design? What happens if my course doesn't have any design? We need to explore and we need to introduce. I will give you some example of what we have done in our department. We had a course like electromagnetic field theory, which had only equations and there was no lab and there was no design. So what we did was we wrote a course outcome telling that the students can use any engineering tool and develop a code for any concept in the course. So we brought in a design component by using an engineering tool in a completely mathematical course. That's what we have done. Similarly, for our math teachers also we have told they will also not be able to have design component in their course. So for maths faculty, we said because computer science faculty are teaching programming language, faculty need not teach programming language, but they can simply include a course outcome, use any language and write the code for a concept in mathematics. So we need to explore. Maybe you can include case studies or you can include some component, but then we have to ensure that uh, we are able to address that. I'm not telling design is compulsory in all courses, but I would like to state that design shall be addressed at least 2 courses every semester. I'm not telling every course shall have design component, but please let us ensure that there is a design at least by 2 courses every semester. Every semester. It's a suggestion. Can we proceed? You have a doubt?
Formulate a canonical state-space model for the real system of being within regular.
A canonical, it cannot be a design. There's a question on how about relating canonical state space for the problem. I think that would come under application. Let us not go by keywords. Let us not go by. Is there a design? What's a design? There is some decision. There are a lot of options, and I pick up one and I solve the problem. So that is what will. Let's not go by keyword. And some software tools will look at a keyword and map. We have done when we started. We have also done some mistakes. But let us look at a broader picture. Is there a design component actually being in? So if I look here, design butterworth filter, I'm not giving the specification. I will just give the frequency response and they will make. If I look at digital filter, the student has a choice whether to use FIR or IIR, which method. There are 4 different. He'll come out with a filter, but I'm not specifying. I'm only giving what I need. So when we make a broad specification, the design gets addressed. Is that fine? So let us proceed. Let us go to the next outcome, and this is most interesting. Till now, we saw PO 1, 2, 3. Most of our courses we were able to address PO 1, 2, 3, and to a large extent we can also address it in our written exam. Written exam in the test. We can also address it in the lab. Both are possible. PO 1, 2, 3 can be addressed in the written exam and in the lab. Now, PO 4 is very, very important, essential. We need to comprehend the true essence. Again, if you look at all the words in the PO, we can't address. Whatever is attractive or what highlights what is easy for us to address as a first step is what I have put in a different color. Design of experiments. If you read here, complex conduct investigation, complex engineering problem, research based, and design of experiment, modeling, analysis, interpretation of data, and provide conclusion. Earlier also we got conclusion. Which PO we had a conclusion? Tell me we had a conclusion. PO2. Very good. A very fast answer. We have all participants active even after lunch. That is nice. That's nice because post lunch session is very difficult for all of us. But it's nice to lunch. No, session is interesting. The the session is interesting. Everybody is excited with OBE. That is why we are getting quick answers even after lunch. No other answer is acceptable. Okay. So now what? So we saw a conclusion. Conclusion happened even in PO2. But how was the conclusion there? We took some knowledge. We took a paper, pen. We did some calculation. We applied a law. We took a calculator. We got some number, and we came at conclusion. How is the conclusion here? Cannot happen in the paper and pen. It has to be an experiment. The conclusion that happens in PO4 is through a conduction of experiment. That is most important. Most important. And can we do experiment in a theory exam? We cannot do. So it will be incorrect if any of our theory paper questions are getting mapped to PO4. It's a blunder. We have done in our case. I will show you my question paper of 2014-15 if time permits. We have done this blunder. When we started OBE, I put some nice question and then I was so excited with my question and I mapped it to PO4. That's a blunder I realized today. We have done the mistake. No question in our theory paper can address PO4. Even the AICT examination reforms, if we go through, they are very clear that PO4 cannot be addressed in the theory paper. So this is one thing of caution. How do we arrive at a conclusion here? We have to do an experiment. That is most important. So this is what happens in PO4. Now, next question is, so these are some of the activities, the Bloom's action verbs. And what is important here is we do an experiment and arrive at a conclusion. My next question is, how do we, I will tell you what happens in my lab exam. In my department, in our department, when we do a lab exam, what normally happens is the students come to the lab exam and they pick up one answer booklet. In the answer booklet, there is a question. They write for first half an hour. After their write-up is correct, only then they go to the lab to conduct the experiment. They go to the lab table to conduct the experiment. They do this. They do this even for a programming-based course. Now tell me, through this form of lab exam, are we addressing PO4? Or which PO we are addressing? Is my question clear? This is what we were doing for a long time. We used to conduct some experiments, put a booklet. Every booklet has a question, no sharing of question, no exchange of question. We have some rules for the exam conduction. And first half an hour they will write. After writing, if it is approved, they go to the lab table to conduct the exam. By this form of lab conduction, which PO are we addressing? Are we addressing PO4? No. Which PO are we addressing? Yes, we got some answers there. What are the answers you're getting? Yes, ma'am. So are we yes? Are we addressing PO4? Is it yes or no? No, he said yes. Please answer in the. We're addressing PO4 by this method. He's telling yeah. He's telling yes. He's telling no. We like to see a no. Yes. So we are not addressing PO4 when they do. Yes, we are addressing PO3. Okay, PO3 will take. So this is of caution. This is of concern for us. We need to plan our lab. Yes, we are getting. See, no. That is so nice. So all the people, faculty who are attending here also, they are telling. So there is a need to relook into the way we conduct our lab exam. We have to explore how to address PO4 through our lab sessions. Please think it over and come out with solutions. I will give an example of how we are trying to address PO4. Yes, Sri Rangam has raised a hand. Yes, please.
Madam, good
Please
afternoon,
speak
madam.
out.
We are from Government Engineering College, Srirangam, madam.
Yes.
For example, I am handling the subject mechatronics and IoT. Am I audible, madam?
Yes, sir. Please go ahead, sir. Very clear.
The subject mechatronics and IoT. In that, we are having only up to P3 only we are having, madam. Design component we are having. We don't have any PO3 4 component. There is no modeling in that. We can't do any modeling analysis using data in this course, ma'am.
Okay, sir. Thank you for raising it. I'll give you some examples of how we are trying to address PO4. You can think it over how you can address it, including it in your course. So what we have done,
we are following the Anna University syllabus, madam. We did not get any autonomous status now. We are following Anna University syllabus. In the syllabus itself, they are not having PO4. It's not possible to have PO4 component here, madam.
You are affiliated to Anna University, and we have a team from Anna University attending. As a faculty, you can definitely do some additional experiments as part of internal teaching and assessment, even though we are affiliated to the Anna University, because you need to read the syllabus, the laboratory experiments that the university has recommended. I'm sure if faculty do one or two additional experiments, I assume there will not be an issue. So this is a statement I am making, but however, please check with the university whether we have permission as faculty to conduct one or two additional experiments. Please check that. My assumption is every Anna University would be glad to see such initiatives by the faculty. If only in internal assessment we are looking, we are not looking at a semester end assessment. This is what I am assuming. Do we all agree to this? Yes, internal assessment. Can I ask, can I not conduct one extra experiment in the lab? Whatever Anna University required, I will do. In addition, I will do one experiment as an internal assessment. Assessment model will not change. We are bound by the university guidelines. So now, how we have tried to address PO4. Normally, our lab experiments would be obtain the transfer function, obtain the VI characteristic, or we always get obtain. This is what our experiments would be. But because we realized that we are not addressing PO4, instead of doing that, we gave them a black box. We used to put some components inside, seal it, give only input, output, and ask the students to conduct the experiments and identify what is inside. So we didn't change the syllabus, we didn't do anything, but one experiment involved this. It could be a simple RC or resistor diode, but we were doing it because we realized that we are not addressing PO4. So that is what we said, black box. Another method of addressing PO4 is, suppose I buy I have an IC, say an operational amplifier, a transistor, a resistor, or any equipment component that we use in the lab. It comes with a specification sheet, and we ask the students conduct experiments to verify the specification. So there's an investigation happening, and he will tell the specifications are matching, not matching. Simple, anything. What we do is we have 10 experiments as such. We try to do one or two additional experiments as to address PO4. We have not brought in drastic changes in the form of laboratory conduction. And one more example. So as I said, the black box is one example. And when they do this, what we put inside, he'll conduct experiment, classify linear or non-linear. I put something inside, I seal and give, he will do and then come. Simple experiment. I'm looking at only third semester. I have normally taught only third and fourth semester courses. I mean, I believe in giving the fundamental concept and obtain the order of the system. He'll conduct the experiment and obtain the order of the system. He'll classify the type of filter. So this is what we are able to do in a lower semester course. And as I mentioned, we can also give the component Instead of telling obtain the truth table of the given NAND gate or obtain, we can remove the name and ask the student conduct experiment, identify the IC given or the component given. So these are all simple possibilities. By just looking into a lab course without change in content, without change in syllabus, we can add 1 or 2 additional experiments to the lab component. I think that is possible even if we are affiliated or we have the academic autonomy. 1 or 2 experiments additional to address PO4. So verify parameters in the data sheet. Another is all of us use engineering tools and conduct an experiment in the lab using real equipment, real components, real devices. Repeat the experiment using a simulation tool and compare. Are they same? They're not same. Where do they differ? Tremendous learning happens here. Tremendous learning happens here. We are okay with being same or different. And it is possible to explore this component in all branches in few courses. Do it in the lab, repeat it in a simulation tool. Do we agree? And in case there is a difference, tomorrow some of our students may join the industry which is making the simulation tool. He knows where to fix the problem and he realizes where the difference is. So these are some examples for addressing PO4. And so that was one example. And if you look PO4, they have also marked to research. There is some comment. They have also mapped. What did they write? Yeah, okay. Since there is emphasis on research, if we look at PO4 in bracket, they have put WK8. And what is WK8? What is WK8? Research literature. So we have to, yes, you can close the chat, yeah. So yes. So another way of addressing PO4 is because it is mapped to WK8, we need to develop the research skill in our student. So I have put an example of a course outcome here that can address research. And what's the example I have put? Identify a recent research work in the domain. My course is signal processing. So I want the students to identify a recent research work. And what should they do? They should summarize or paraphrase. So they will just present in 4 or 5 sentences what is happening in the research. What is another possibility? They reproduce the document. What I mean by reproducing the document, they type the whole document, they type the equations, they type the graph. Not literature survey. They just reproduce typing, technical documentation skill. I'm looking at the skill to just reproduce the paper. By reproducing, I mean they need to learn how to type an equation. It could be in Word, it could be in LaTeX, it could be any platform. So they type the equation. They have a figure how to reproduce a graph. So enter some data and reproduce the graph. So they will learn the skill of technical writing and technical documentation. That is one component. What's the another component? Reproduce the results in the research paper. It's possible. It's possible. You give them the task, type all this document, they will type it. If you only thing we have to mention it as a course outcome. I have put it little large here, but you see what we can do. And we are looking at undergraduate students, so don't ask them to do too much. Don't ask them to do too much. We are looking at trying to address through our undergraduate courses, through our core courses. Don't think that I'll put one course in research method in the curriculum and they will take care of research. No, that's not the answer. We have to look introducing research skills through our courses that we are teaching. So that is our responsibility, and that is what happens. So now there are 3 components here. One is they can read and summarize the paper. Next is they simply reproduce by using a text editor. Next is they can reproduce the results. So they have to select a paper where the results can be reproduced. Because they know what facilities we have, or we can only give the paper and ask them to reproduce. So, and this cannot be addressed again in a theory exam. This cannot be addressed maybe even in the lab exam. It happens as a deadline. By 20th of September, submit the report. So it's a deadline and rubrics. That's what happens. And let us see. I have given an example here. I've given a paper here. This I little what should I say? This is specific an example of a paper, and they have to type the entire two activities that I've listed. One is they have to type the paper. They have to reproduce 80% of the results. And specific to the faculty from the ECE domain, I want you to read the paper and explore implementing the paper because it focuses on introducing analog signal processing. Our syllabus has digital signal processing but does not have analog signal processing. So this is something another component. So similarly, I have another paper here, a publication 2023. And here I have what's the question they have to answer? They have to just answer two questions. What is experiential learning? And next, list the concepts where experiential learning is used. So the paper, even if they spend 10 minutes reading the paper, they will be able to answer these questions. So we are looking at undergraduate students, but it gives them an idea on possible skill that is possible. Next one. Here again, I have another publication, all related to my undergraduate course only. My course is Signals and Systems. Related to that course, I've given another paper, and the questions that they need to answer. What is SSCI? And so these are some ways of trying to bring in the research skill in our courses. If we give the paper, that becomes very easy. And if we give our own paper, that's the best thing. Otherwise, we give someone else's paper. So there's a lot that can be done. All are my own papers, except this one. And this is, yes. So now, having seen PO4, it's thought. I'm not sure whether we will take up the task of writing. Now onwards, I think we will go ahead quickly discussing all the POs, and then we will write the course outcomes at the end, because we can't take up one by one because we have so much, all the POs to be addressed. So I assume how to address PO4 is clear. There has to be an investigation, a conclusion that comes through experimentation, cannot be addressed in lab exam, nor in the, cannot be addressed in the theory exam, can be addressed in the lab exam. And research skill cannot be addressed either in theory or lab. So two components here. So now let's go to PO5, the engineering tool. Create, select, apply appropriate techniques. And yes, so engineering tool, all of us know we are all using tools for our courses. So this doesn't need too much of a discussion. And I've listed some examples of the tools that that we are possibly using for our courses. Yes. Yeah. All. Yeah.
Simulate the power electronic converter and validate the result with a theoretical.
So there are. I'm not going to take up for discussion, but then the tool can be. We may use a proprietary tool or an open source tool. We will use a tool for our course. And what do we recognize here? What we recognize is using the tool, depending on what I make my students to do, I can address Bloom's level 1, 2, 3, 4, 5, 6. It depends on us. What questions we are asking, what activity we are asking them to do. In the written normal lab exam, I would have done find the largest element of the array. I'll give the same question in the exam. And what am I testing? Am I testing is coding skill or memory skill? So that is where of serious concern. It is in our hands, we the faculty, how we want to use the tool. Whether we want to address design, whether we want to address analyze, or we want to address evaluate. So it depends on us. Toolbox is something I am very passionate. I'm sure we have used toolboxes. How many of us have used any signal processing, control system toolbox? Yes. Toolbox, control system toolbox in MATLAB? Yes. Have we used toolboxes? Yes. Can you type in which toolbox you have used, or you unmute and speak? Or just type in which toolbox we have used. For any answers? Yes? Any toolbox? Communication system toolbox is one answer. Image processing toolbox, very nice. Yes. Yeah. So we got one answer, communication. We got signal processing, communication toolbox. What is that? Simulink. Yes, Simulink is, yes, for solving equations. Yes. So what is the point here? I want to have a course outcome, develop the toolbox. Develop the toolbox. Image processing toolbox, we can't do as good as MATLAB, or we can't do as good as the professional. We may have 10% of the features, but this toolbox we developed by ourselves with our students writing a function. My suggestion or a strong recommendation is, please explore developing at least 2 toolbox in the whole curriculum. Is it clear? We don't use toolbox. We show them the toolbox and tell them reproduce the toolbox. Do we agree tremendous learning happens? Yes. So this is a suggestion. Please write it down. Someone has raised a hand.
Madam, Madam,
Yes, sir. Please go ahead, sir.
IIT Bombay already developed signal processing and control system communication system toolbox for using Scilab, which is compatible with MATLAB, madam. It's available in scilab.in website.
Yes, thank you for bringing out this component. Thank you so much. So what is happening at the end? We appreciate the efforts by IIT Bombay. The team at IIT Bombay, they have developed the toolbox.
I am one of the team member, madam. I am one of the team member.
I want to see a toolbox developed by the team members, faculty team at ERO.
Yeah,
This
I am
is
one
what
of the
we
team
want.
member.
This is what we want. May not be as good as what others have done. We will do a very simple toolbox. Well, then only our students will learn. Using a toolbox is one component, developing the toolbox is another component. We have to raise the bar. We have to develop our toolbox for our course. It's a suggestion. Please explore.
Madam, the toolbox developed by me. I am one of the team member. GCE Road.
Okay.
Yes, madam.
Okay, sir. We appreciate. So you have developed the toolbox along with the team at IIT Bombay. That's wonderful. We appreciate. We appreciate the process. Very nice. GCE Road are able to have the same skills in developing the toolbox. Thank you, sir. Very good initiative. Very good initiative.
Madam, that is available for free for all over India. That is available.
To do their own toolbox.
Yeah.
We want everyone to develop their toolbox. We want everyone to develop. I hope everyone agrees to this suggestion. A simple toolbox may have 100 features. Let us do a small. The finite element method FEMLab by MATLAB for solving partial PD different equation. We can do a small version. So let's explore. This is the highest form of an assessment, the best form of assessment. Ask the students to do a toolbox for mathematics concepts. Ask the students to do a toolbox for physics. Just put it as a course outcome, the students will do it. And the learning enhanced. It won't be as good as a commercial one because there is a huge team working with a lot of effort. We are doing in one semester with our undergraduate students. So this is at this rate I will not be able to cover. Yes. So moving further, I have an example for the analog signal processing course, the same signals and system, the corresponding lab. For this lab component, I have written 4 course outcomes. 4 course outcomes, and I have mapped it to the POs. The first course outcome is being able to convert equation to code. Second one is analyze the code and write the equation. The third one is a design component, and the last one is build the toolbox. We have built the toolbox through our 10-12 sessions of the lab without any prior knowledge in any either Python or multisim. This is what we have done. We start off how we have done it. First week as a calculator, second week plot function, third week we have statistical averages, and 12 weeks we have built this. All our students have this toolbox that we have developed in the 12 sessions, and they can bring this toolbox to the lab exam. They can bring the toolbox to the lab exam. That is how our lab exam is designed. Open record. I mean, open resource exam, they can carry this. We build the toolbox, they can carry it to the lab exam. This is just as an example. And so I just want to emphasize that it is in we the faculty, how we are going to use a tool for our students. And one more component I would like to emphasize here is uh, in the initial years when we have started our career, we have referred to graphs and tables at the end of the book, because those days the computation facility was not high. Today, all these tables can be generated by 4 or 5 lines of code in the lab. So we have to, one lab experiment can be simply generate the table at the back of the book. Do we all agree? Yes, so we need to explore. We can't still continue, take the book, look at row number, column number, Gaussian table, normal curve, error function table. That cannot happen. We need to move away from referring to these tables, and we should be able to generate it because computation tool facility has enhanced like anything. Student has so much of computation power in the devices that he has ready access to. And yes, when we graduated with textbooks, and this was our treasure. But today, when our students graduate, we will all agree that they are not going to carry textbooks, and we all agree. Yes. So what will they carry? They will carry blocks of working code for every concept they have studied in the 4-year engineering program. This is my dream, and I am sharing my dream with you. You please implement it. This is a dream. When the student graduates, he will have a working code for every concept he has studied in the exam, because this is the next generation. There's a generation gap, and we need to give them what they require. And preferably, if we can do it with any open source programming environment, it becomes beneficial. Otherwise, if we use any proprietary tools, the day they graduate, he will not have access to the tool. All the code that we develop will not be functional. So let us be careful here and go ahead. And yes, I think this we need to look here. If you look at every course, this is a new structure of the curriculum. The curriculum does not have an LTP structure. It has hours allocated, and it is for the faculty to decide how they want to distribute the hours among lecture, theory, and most important, every course has a self-learning component. This is most important. Every course has a self-learning component. This is the NBSR. Please refer to it. And they have come out with this model by looking at the National Credit Framework. So the curricular structure itself changes. This has to be referred to when we are making the new curriculum now. I think many members who are attending the session here are going to be involved in the design and implementation of curriculum. They are likely to be BOS members. Please look at this and have this component when we prepare the courses in the curriculum. So I think you can write some example, but because of lack of time, we will proceed further. Anyway, you will be completing all this activity and sharing it as a on Monday evening. You will share it in the Google form. Today you will take a simple exercise, a small quiz type of thing that we'll have at the end of the day. Again, shared through a Google form. So we will, in case we have any doubt, we can take it. Otherwise, we will move ahead. So now we have seen till PO5. PO5, we address all the Bloom's level, all Bloom's levels are over. And till PO5, we can address in our written exam, lab exam. So conventional exam, either lab or theory component is done. Now onwards, someone in the morning, they said, we want clarity on how to address PO6 onwards. So that is what we are going to answer now, how to address PO6 onwards. Now these POs from PO6 onwards, we cannot normally address in a written exam or in a lab exam. So it will come through other alternate forms of assessment that we include for assessing a student. So now let us look at engineer and the world. It looks at sustainability and environment. As we know, our earlier PO6 and 7 got combined